the main focus of this course, of this lesson, will be the prime factorization, okay? Previously, we decompose a number in this way: 30, 1 times 30, 2 times 15, 3 times 10, and then 4, 5 times 6, okay? 6 will be 6 times 5, it repeats itself. So we stop here. We decompose it like this to get back all the factors, okay? Now, we don't want to decompose it in this way because it seems quite complicated. We have to check the numbers one by one, okay? We have to check from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have to check it like this, okay? It is too tedious. We want to find a better way to do it, okay? We this time decompose the number in this way. We decompose it to be 2 times 3 times 5, okay? We want to write it as products of prime numbers. They are all prime numbers, okay? If we can write a number in a product of prime numbers, okay, we call it a prime factorization, okay? So for 24, we can write it as 2 times 2 times 2 times 3, okay? We say it is a prime factorization of 24. We break down 24 by prime numbers in form of their products, okay? So for like 90, we can decompose it as 2 times 3 times 3 times 5. They are all prime numbers, okay? We call it, they are the prime factorization of 90, okay? Now, you will learn how to find these numbers, okay? You will need to know how many numbers 2 are there, how many number 3s are there, how many number 5s are there, okay? This is what we are going to do, okay? Now, there is one special thing about this prime factorization, okay? You can think about this part. Every whole number greater than 1 is either a prime number or a composite number. The composite number can be expressed as a unique product of its prime factor, okay? This unique product, it refers to this one, which is the prime factorization. We call this the prime factorization of the number, okay? For 280, okay, we can decompose it to be, just a moment, to be 2, 2, 5, and 7, okay? So how are we going to decompose it in this way? Oh, I missed the 2 here, okay? We make use of the division, okay? If you still remember they are factors, that means the remainder is 0, okay? So we do the division, okay? Now we begin with 280, decomposed by the first number, prime, there is 2. You will get a quotient of 140, okay? 280 decomposed by 2, you will get 140 here. Then we further decompose 140 with 2 and 70. Okay, 70 divided by 2, 140 divided by 2, it will be 7. Okay, 70. All right, and then 70 further decomposed by 2, you will get 35. Okay, half of 70 is 35. And then 35, you can decompose it by, okay, 3, no, not possible. By 5, you will get a 7, okay? So you will get 5 and 7, okay? So how are we going to write to obtain this expression, okay? Now, for all the division here, you will see that they all have the remainder 0, okay? So later on, we don't want to separate the division into so many steps. We want to group them, okay? We want to simplify our division, okay? So first of all, we decompose it to be 2 times 140. And then you know 140, you can switch it to 140, you can switch it to 2 times 70, okay? And then this 70, you can further decompose it to 2 times 35, okay? This 35, you can further decompose it to 2 times 2 times 2 times 3 and 5, okay? 3 and 5. That's how you obtain, sorry, not 3 and 5, it's 5 and 7. That's how you obtain this expression, okay? This expression is the prime factorization of 280, okay? That's how we do it. Now, for getting this expression, it involves a lot of division, like what I have done here, okay? We think if the number is very big, having so many division is not very nice in our calculation. It makes our calculation tedious, okay? So we invent another kind of division called the short division, okay? We group all the division here into one. Now, the reason for us to group them into one is because we know all the remainder must be 0. So the remainder is not important. It is the quotient which is important, okay? So in the short division, we just focus on the quotient itself, this number, okay? We begin by 280, okay? We write it like this, the short division, divided by 2, okay? So we have 1, 2 divided by 2 is 1, 8 divided by 2 is 4, and then 0. And then further divided by 2, okay, it will get 7 and 0. And then further divided, it will be 3, 5. And then further divided by it, it will be 5 and 7, okay? How to get all the numbers in the prime factorization? You just take all of them, okay? Take all of them, and then you will have every number here. This is called the prime factorization of 280, okay? So in the remaining time, we will use the short division instead of this decomposition, okay? The short division provides you a more accurate and clear way to get all the factors. Now, you have 1 to 6, express it as a product of its prime factors. That means I want the prime factorization. 1 to 6, okay? Remember, I've asked you, all even numbers are composite numbers because they are divisible by 2. So I first try 2, okay? 12 divided by 2, you will get 6. 6 divided by 2, you will get 3, okay? 63, it is a multiple of 3. So 6 divided by 3, you will get 2. 3 divided by 3, you will get 1. 21, if you still remember, it is a multiple of 3 as well. So we get 21 divided by 3 is 7, okay? Now, up to 7, 7 is a prime, you can stop. So you take all this number, okay? Take them out and write it as 2 times this 3 times this 3 times this 7. It is the prime factorization of 1 to 6, okay?